T-test for studying differences. It is considered one of the most commonly used statistical transactions in studying differences and is a parametric statistical method used to compare the means of two groups in experimental, quasi-experimental, and comparative descriptive studies. The following conditions must be met before applying it. The distribution of the samples must be normal. The sizes of the samples must be similar. The size of each sample must not be less than 30 individuals. The samples must be homogeneous. Types: 1 sample t-test, 2 sample t-test, paired sample t-test. Independent datasets: 2 sets of data for 2 different groups of individuals, each with 1 score per individual. Related datasets: 1 group of individuals, each with 2 scores. 1 sample t-test. It is used to compare the mean of a single sample with the population mean. This test is used when we have a sample and want to verify whether it accurately represents the population mean or not. 1. Steps to perform the 1 sample test. 1. Formulate the hypotheses. The null hypothesis, H. It assumes that there are no differences between the sample mean and the population mean. Alternative hypothesis, H. indicates that there is a statistically significant difference between the sample mean and the population mean. 2. Calculate the statistics. The 1 sample t-test is calculated using the following formula. X is the sample mean. Mu is the population mean. S is the sample standard deviation. N is the sample size. 3. Make a decision. Making a decision involves rejecting or accepting the null hypothesis, and to do this, we must compare the calculated t-value we obtained with the tabulated t-value. To obtain the tabulated t-value, we calculate the degrees of freedom, which is df equals n1, i.e., the number of sample members minus 1. If the calculated t-value is greater than the tabulated t-value, we reject the null hypothesis and accept the alternative hypothesis. If the calculated t-value is less than the tabulated t-value, we accept the null hypothesis and reject the alternative hypothesis. Exercise. If we have a study population consisting of 250 first-grade students and we took a random sample of 30 students from Class 1B, and found that the mean score of the students in Class 1B in the science subject is 14 degrees, and the standard deviation is 2.94, knowing that the mean score for all first-grade students is 15 degrees, is there a statistically significant difference between the average of the students in Class 1B and the average of all first-grade students? Research question. Is there a difference between the average of the students in Class 1B and the average of all first-grade students? Hypothesis formulation. 0H. There are no statistically significant differences between the average achievement of students in Class 1B and the achievement of all first-grade students in the science curriculum. 1H. There are statistically significant differences between the average achievement of students in Class 1B and the achievement of all first-grade students in the science curriculum. Determining the level of significance, let alpha equals 0.05. Interpretation. The calculated value of t, Tc equals 1.88, is greater than the tabulated value of t, Tt equals 1.69, so we reject the null hypothesis and accept the alternative hypothesis. Decision. There are statistically significant differences between the average achievement of first-grade students in Class A and the achievement of all first-grade students in the science curriculum. 2 sample t-test. Use 2 sample t-test to compare the mean of precisely 2 groups, no more and no less. Have the following hypotheses. H0 equals the means for the 2 populations are equals. H1 equals the means for the 2 populations are not equal. #2. Calculate the statistics. The 1 sample t-test is calculated using the following formula. df equals n1 plus n2, -2. X. We have statistics exam scores for 2 independent samples. A sample of social science students. An independent sample of economics students. Objective. Determine whether there is a statistically significant difference between the mean scores of social science students and economics students in the statistics exam. Solution. Research question. Is there a statistically significant difference between the mean scores of social science students and the mean scores of economics students in the statistics exam? Hypotheses. Null hypothesis, H. There is no difference between the mean scores of social science students and economics students in the statistics exam. Alternative hypothesis, H. There is a difference between the mean scores of social science students and economics students in the statistics exam. Decision making. Calculated t-value, t_calculated, equals 0.17. Critical t-values, t_tabulated, for a two-tailed test, non-directional hypothesis. At proportionality equals 0.01 t_tabulated equals 3.055. At proportionality equals 0.05 t_tabulated equals 2.179. Comparison. Since 0.17 less than 2.179, we fail to reject the null hypothesis, H, at proportionality equals 0.05. 5. Interpretation. There is no statistically significant difference between the mean scores of social science students and economics students in the statistics exam, x equals x. Paired samples t-test. The paired samples t-test aims to test hypotheses regarding the differences between the means of two related samples. The related samples refer to a single sample with two measurements. This is done by comparing the calculated value from the equation stated below with the critical value obtained from the t-distribution table.